Hello everyone, welcome to the demonstration of data structures laboratory. Today we people are going to demonstrate experiment 6. Aim of the experiment is to design, develop and implement a menu-driven program in C for the following operations on circular queue of characters. Insert an element onto circular queue, delete an element from circular queue, demonstrate overflow and underflow situations on circular queue, display the status of circular queue and exit. Support the program with appropriate functions for each of the above operations. So circular queue is a linear data structure. It follows first in first out principle. In a circular queue, what happens is the last node is connected back to the first node to make a circle. It follows the first in first out principle. First in first out principle means the element which is inserted first will be deleted first. Here in a circular queue, the elements are added from the rear end and are deleted from the front end. The queue is considered as a circular queue when the position 0 and max minus 1 are adjacent. So here we can see how a circular queue can look like. So an ordinary queue, like it can be represented in a linear fashion. So this is an ordinary queue. Here you can see rear is at position or index 4 and front is at index 0. So here 5 elements are being inserted. If this queue, if we represent it as a circular queue, then the queue will look like this. So a rear here, the representation of this ordinary queue itself is a circular queue here. So this rear is at index 4 and front is at index 0. So at front position that is 0, we are having element 10, then at index 1, 20, index 2, 30, index 3, 40 and index 4, 50. Now this queue is referred to as ordinary, circular queue because you can see the rear and front, they follow one after the another. So after rear, the front follows. So here in the circular manner, the elements can be inserted in the circular queue. Now, if at all we want to delete an element in a queue, says this is an ordinary queue. If I try to delete 10, then here there will be no element. Now, if I try to insert the element in this queue now, insertion is not possible. Why insertion is not possible? Because rear value is 4. So according to the ordinary queues implementation, if rear is equal to max size minus 1, it indicates that the queue is full. Now rear value is 4, size of the queue is 5. So 4 is equal to max size minus 1. So this condition is true. So this indicates that the queue is full. As the queue full condition is satisfied, it is not possible for us to insert the element. But we already have one position here and this position we can insert. But according to the implementation of the ordinary queue, this insertion is not possible. So this is one problem what we face in the ordinary queue. Similarly, if one more element is been deleted, that is 20, then we will be left out with 2 empty positions. But in the ordinary queue implementation, in these 2 positions also the insertion is not possible because rear is still at 4. So according to that, the queue is full itself. So how to overcome this? So in order to overcome this disadvantage, the circular queue is being used. So here in the circular queue, to overcome this problem, what we will do is the rear will be incremented. The rear will be incremented as rear is equals to rear plus 1 mod queue size and the front will be incremented as front is equal to front plus 1 mod queue size. Mod queue size. So by using this implementation, we people are going to increment the front pointer and the rear pointer. See, this way, if the front pointer and the rear pointer is incremented, so the problem what we have faced in the ordinary queue, that problem will not occur further. So here you can see rear is pointing at 4. Two positions are already empty. If we try to insert the element, with an ordinary queue, rear can be incremented by simply adding 1 to it. But here in a circular queue, what we will do is we will increment it as rear value is 4, then 4 plus 1, then mod queue size. Queue size is 5. So this will give us 5 mod 5. So 5 mod 5 becomes 0. So now the new rear value will become 0. So rear can be updated to 0 by using this increment operation, and at this location a new element can be inserted. So this is what the advantage of circular queue we have over a ordinary. Similarly, by incrementing the front using front is equals to front plus 1, the queue can be implemented in a efficient manner. So that's why rear and front are incremented in this way. So this is what the overview of a circular queue is. Now in order to implement this lab program, what we will do is we will include the header file stdio.h and stdlib.h. We will take one variable int size, we take it as a global variable. Then we take one variable choice, one variable count, it is initialized to 0, front is 0 and rear is -1. We take one item character of type character. Then we will take one q variable, that is q of 20. So this program is to read uh, a queue of characters. So we have to create a queue of characters, that is one by one character we have to insert, and then we have to display the contents of the queue and we have to delete the elements of the queue. In this way the program is to be implemented. So as we are interested in creating a queue of characters, so we are taking it as character item here and queue of 20. So queue, this is the queue what we are going to maintain and the size is 20 here. So at higher side we have taken queue size as 20. Now this is the insert rear function. We will understand this later on. Now before moving to this insert rear and delete front function, so first let us have a look into the main function and then we will come back to the all the functions. So in the main function, there is a printf statement which indicates enter the size of the queue. So user has to enter the size of the queue. Now suppose if the user gives the size as 5, then maximum 5 elements can be inserted in the queue. Then we are using a do while loop. Say we want to create a menu driven program. So in that 4 operations are to be performed. So if user presses 1, insert operation should be performed. For 2, deletion. For 3, display. And for 4, exit operation is to be performed. So based upon the task the user wants to perform, the user will hit a choice. That is either 1, 2, 3 or 4. Then based upon the choice, appropriate operation has to execute once. So at a time only one operation should execute. So switch statement is being used. If a user hits 1, then case 1 will be executed. If user hits 2, then case 2. Similarly, case 3 and case 4 will be executed. In case 1, we will call the insert rear function. So here, before calling the insert rear function, the user has to enter the element to be inserted. So here, with the help of a scanf statement, the item we want to insert, we will read it. Then we will call the insert rear function by passing the item parameter and break. In the second case, we will call the delete front function. In the third case, we will call the display function. We'll pass the front pointer and the count. And after every case, we will break. Then in case 4, we people are going to exit the program. So simply we'll display a message such as thank you and we will just terminate. If a user presses other than 1, 2, 3, 4, then in the fifth, say other than 1 to 4, if any other number is been pressed, so even that choice is to be handled by the program. So in the default case, we will just display a error message such as invalid choice. So this do while will repeat until unless the choice is not equal to 4. So in this way, in the main function, the menu driven part of a code can be written. Now assume that we want to insert the elements into the circular queue. So for that, we will try to understand how insertion can be done. So for me, it is not possible to draw a circular queue here. So I will be using a linear queue itself, but you assume that it is a circular queue only because I cannot draw a queue in a circular manner. So I'll be using it in this way only. So assume that we have the queue size as 5. So the maximum indexes will be 0, 1, 2, 3, 4, and initially this queue is empty. So initially count a variable we have taken, so count is 0, and size we have taken it as 5. That is, we have assumed that the maximum size of the queue is 5. So before inserting, you have to check whether the queue is empty. Queue is full. So for that, you will check the condition if count is equal to size. Now count is 0, size is equal to 5. So this condition will not be executed. This condition becomes false. As this condition becomes false, this indicates that the queue is not full. So we'll move to the else part here and rare will be incremented. We know that in the above declaration itself, we have declared count 0, front 0 and rare -1. So our rare is -1. Now it is a circular queue. So rare will be incremented as rare is equals to rare plus 1 mod queue size. So now we will obtain rare is equal to rare plus 1. So rare already we have taken it as -1 plus 1, then mod queue size. So this mod queue size, it will give me -1 plus 1, it becomes 0. Then 0 mod 5, 0 mod 5, we will get it as 0. So R value is 0. So in queue of R, item is to be stored. So assume that we want to insert an item that is 45. So after inserting an element at Q of R, so R value is 0 at Q of R, the item to be inserted, we have inserted. After that, the count should be incremented. Now count was 0. After inserting, the count has become 1. Now again, in this way, we can keep on inserting the element until unless the queue is full. So again, the insert rare function will be called. Then again, you have to check whether the queue is full. So count is 1. Then size is 5. Check whether count is equal to size. So this condition is still false because count is 1 and size is 5. So this condition is still false. So what we have to do, rare should be incremented. So rare can be incremented as rare is equals to rare plus 1 mod queue size. So rare value now it is 0. So 0 plus 1 mod 5, it will be 1 mod 5. 1 mod 5, the answer is 1. So now rare value has become 1. So at position 1, we can insert one more element, say 60. In the same way, one more element can be inserted. So before inserting, when the insert rare function is called, again it will check whether the queue is full. So the condition to check whether the queue is full is whether count is equal to size. So this condition is false because we have inserted second element, count has incremented to 2. 2 is equal to size, it is false. So the rare has to be incremented. Rare value is 1 in the above iteration. So 1 plus 1, we will get it as 2. So 2 mod 5, we will obtain rare value as 2. So rare value as 2. So in the position Q of 2, a new element can be inserted. After inserting, Q should be count should be incremented. Count will become 3. So again, we want to insert fourth element. So for that again we will check whether the queue is full. Count is 3 now, size is 5, 3 is equal to 5, the condition is false, so queue is not full. Then we'll move to the else part. Now the rare should be incremented. So the rare will be incremented as rare is equal to rare plus 1 mod queue size. So rare value is 2, 2 plus 1 mod, 2 plus 1 becomes 3, 3 mod 5, we will get it as 3. So at Q of 3, one more element we will insert. Then again for inserting the fifth element, again we will check whether the queue is full. Again the queue is not full because count is equal to size. This condition is not satisfied, it is false. So we'll move to the else part. Then again the rare is to be incremented. So rare can be incremented as rare is equals to rare plus 1. So rare in the previous iteration is 3. 3 plus 1, we get it as 4. So 4 mod 5, we will get it as 5. Then it is possible for us to insert the fifth element at q of, there is 4. So at q of 4, fifth element can be inserted. So we'll insert the fifth element. Then we will try to insert the element at the sixth position. So now the count has become 5. We have already inserted 1, 2, 3, 4, 5. So 5 elements we have inserted. The count has become 5. So once the count has become 5, so we will try to insert the element for the sixth time. So for that again we have to check whether the queue is full. So we'll check for the condition. If count is equal to size. So count is 5. Queue size is 5. Count is equal to size. This condition becomes true. As this condition becomes true, now we will display Q is, we will display what? Q is. So in this way, the elements in a circular queue can be inserted. So it is not possible for me at this moment of time to draw a circular queue, and in this the element can be inserted. So in this way, in the circular queue also the elements are inserted. So this last end and this last end, if I join it in a circular fashion, then it will become a circular queue. So you imagine that it is a circular queue itself. So this is how in a circular queue using insert rare the elements can be inserted. Now here in this program, we are not inserting numbers, but we are inserting characters. That I just forgot to tell you. So this we are implementing two of characters. So we have taken the character items and one by one the character elements we are inserting. We had assumed while tracing that numbers we have inserted. So assume that we are inserting the characters. Now this is what the queue we have created. Now we'll try to see how these elements can be inserted from the circular. So for deleting in a circular queue, we have to implement delete front function. So assume that we are having this queue already which we have created. In this there are 5 elements. So count we have is 5. That is, as we have inserted 5 elements. So here we are having count is equal to 5. So count is already updated. So count has become 5. So for this queue which has been inserted, count is already 5. So while deleting, always we have to check whether the queue is empty. So for that you have to check the condition if count is equal to 0. Now our count is 5. This is not equal to 0, so it is false. So this if statement will not execute. Then we have to move to the else part and we have to display the deleted item. So the deleted item is percentage C Q of F. So F, what is the F? We have passed F value in the beginning of the program itself. We have taken it as 0. So F is a 0 initially itself. So we know that at the beginning of the program itself, F was 0. So the same F value we will be taking it. So now we have to display Q of F. So Q of F means F is 0. So Q of 0 we will display A. Then F value will be incremented as F is equal to F plus 1 mod size. So F value is 0. 0 plus 1 mod. So this we will get 0 plus 1. 1 mod 5 we will get it as 1. Then count should be decremented. Now count will become 4. Earlier it was 5. Now it has become 4. In this way, one by one, the element we can delete. So every time while deleting, we have to check whether the the queue is empty. So here we have to check whether count is equals to 0. It is false. Now front value in the previous iteration was 1. So display Q of F. So F value is 1. So Q of 1 we have to display. It is B. So B will be displayed. Then front has to be updated. Now front will become 1 plus 1 mod 5. So 1 plus 1 mod 5 will become 2 mod 5. 2 mod 5 will become 2. Then again the same operation is to be performed. Again the same statements we have to check. Again we have to check whether count is equal to 0. We have already deleted 2 elements. So count is 3. Every time while deleting, check whether the queue is empty. Then decrement the front. Sorry, it's not decrement. It is increment the front. Then delete the element. Now front value is 2. So delete f of 2. So f of 2 it is 3. So delete it. Then increment the front. So front will be, in the previous iteration front is 2. So 2 plus 1 mod 5. 2 plus 1 is 3. 3 mod 5 we will get it as 3. Then again we want to delete the element for the fourth time. So before deleting you have to decrement the count. So count will become 2. So 2 more elements are left out. So for that again you have to check whether the list is empty. You have to check the same condition. Count is equal to 0. It is false. Then the deleted element is, so the deleted element is which one? Q of 3. So Q of 3 is D. So delete it. Then update F. So F will be 3 plus 1 mod 5. So 3 plus 1 mod 5 we will get 4. So this is 3 plus 1, it becomes 4. Then 4 mod 5 we will get it as 5. Okay. Then 4 plus 1 mod 5 we will get 4. Now the front is 4. So we have deleted the fourth element. Again decrement count. Count will become 1. So again while deleting the fifth element, again you have to check whether count is equal to 0. So we will take count is equal to 0. This condition is false because count is 1. Then we have to delete the element at front. So front is 4 now. So at front 4, delete the element that is E. So display deleted element is, display deleted element is E. After that increment front. So front is equal to, front is equals to, front value in the previous iteration is 4. 4 plus 1 mod 5. So 5 mod 5 we will get it as 0. So front has become 0. Okay. After that we have already deleted 5 elements. So after deleting it, count will become 0. Now we try to delete the element at the 6th time. So we have to check whether count is equal to 0. Now here people can see count is equal to 0. So this condition is true. As this condition is true, here at this moment we will display what? At this position we will display Q is. So in this way, in a circular queue, the elements can be deleted. Now, next function we'll try to understand is how to display the contents of the queue. So we will assume that we already have 5 elements in the queue. So initially our count is now 5 because there are 5 elements already in the queue. So while deleting the elements of, sorry, while displaying the elements of the queue, first thing the queue is empty. Now here count is 5. Count is not equal to 0. So this if part will not execute because queue is not empty. So we have to move to the else part. In the else part, we have to display elements of the queue. So elements of queue. Queue is also called as a list. Elements of the queue are, then for I is equal to 1. Now we are having I is equal to 1. We have taken the for loop here. So I is equal to 1. I is less than or equal to count. So count is our 5. So count is above 5 because we are having 5 elements. So I is 1 is less than equal to count is 5, the condition is true. So what we have to do? We have to print Q of F. So F is 0. F is 0 because F we have taken it as a global variable. Every time a function is been called, then the front value will be reinitialized to 0 itself. So front is 0. Then this I is equal to 1 is less than count, this condition is true. Then what we will do? We will print A. After that front will be incremented. Now front will become front plus 1 mod size. So front is how much? 0. So 0, 0 plus 1 mod. So 0 plus we will get it as 1. So front will become 1. Again the for loop will repeat. So now as the for loop repeats, now I value will increment. Earlier I value was 1, now I value is 2. 2 is less than equal to count. Count is 5 itself. 2 is less than equal to count. Condition is true. Then we will display Q of F. F is 1. So at Q of 1 we are having B. So display B here. So we will display B here. Okay. After that front should be incremented. So front will be incremented as front is equal to front plus 1 mod Q size. So front in the previous iteration is 1. 1 plus 1 mod 5. We will get it as 2. So 2 mod 5 is 2. Then again the for loop will repeat. You have to check I value becomes P is less than equal to count. Condition is true. Display Q of F. F is 2 in the previous iteration. So Q of 2. Q of 2 is C. So display. Then increment front pointer. The front will be 2 plus 1 mod 5. It becomes in the same way. In the same way, I value will for loop will be repeated. I value will become 4. 4 is less than equal to count. So at F of 3, we have element D. So D will be displayed. Then front will be incremented. It will become 3 plus 1 mod 5. We'll get 4. Then again the for loop will repeat. So I value will become 5. 5 is less than equal to count. The condition is still 2. So at Q of 4, we have E. So E will be displayed here. So E will be displayed here. Then front will be incremented. So front we are having it as 4. So 4 plus 1 mod 5. So front will become 0. So 5 mod 5 we will get it as 0. Then once again we will try to repeat the for loop. So I value will become 5. I value will become 6. Sorry, it is not 5. I will become 6. 6 is less than equal to count. The condition is false. Because count is 5. I value has become 6. 6 is less than or equal to 5. The condition is false. So for loop terminates. Hence, all the elements in the queue we have displayed, and hence we will terminate the display function. So this is how the elements in a queue can be displayed. So in this way, this experiment 6 can be implemented. So the sample output is the user will be displayed with the following options: insert, delete, display, exit. So one by one, the user has to give a choice. If the user gives 1, then insertion is possible. Then one by one, the elements are to be inserted. Once all the elements are been inserted, if the user wishes to display, then the user can give choice as 3. Then the contents of queue will be displayed. Then if we try to insert the elements more than the queue size, then queue full will be displayed. Then if at all the user wants to delete the element by pressing Choice 2, the elements can be deleted one by one. Once all the elements are been deleted, the queue empty condition will be executed. Okay. In this way, the circular queue can be implemented. Now let us try to execute the program. We'll go to Turbo C. I have already tried then we have to execute the program. So for that we will click on run, or we can press Ctrl F9. Then it will ask me to give the size of the queue. So I have given the queue size as 4. Now I have to insert the element. I will give choice as 1. So I will insert an element that is A. Then once again I want to insert, I will type B. Then once again I want to insert, I will give choice as 1. The program will display the message, enter the number to be inserted. I will type C. Then after pressing enter, this message is displayed. 1 insert, 2 delete, 3 display, 4 exist. So once again I'll give 1. So it will ask me to insert the number. So I'll give D. Then I'll press enter. Again the 4 options are displayed. Then again I'll give 1. It will ask me to insert one more number. So I'll give E. Now I have already inserted 4 elements A, B, C, D. Above they are been done. I tried to insert fifth element E. It is giving me the output that is queue is full. Now I want to display the contents of the queue. So I'll display 3. So this is the list contents. I have inserted 4 elements A, B, C, D. So this queue content it is displaying. Now I want to delete the element one by one. So for that I'll press 2. So first element is deleted. The first element is A. The Q is a first in first out data structure. So the element which is inserted first will be deleted first. So A was inserted first, so A is deleted first. Now we'll again display and see whether the contents are been removed or not. So we'll press 3. So you can see the remaining contents are B, C, D. Earlier we had A, B, C, D. Now we have deleted A. We are left out with B, C, and D. So once again we'll try to delete. I'll give 2 and delete. The next deleted element is 2. Again we will display. For that we will give input as 3. Then the remaining contents are been displayed. Now I will press 2 and try to delete. One more element is deleted, that is C. I will try to display and give option as 3 and press enter. The element in the list are D. Now I'll try to delete one more time. So it is showing me deleted element is D. Now I will try to display and see if there are any other contents available. So after pressing D, I have got queue is empty. So in this way, the elements in the queue can be inserted, deleted, and displayed. So for terminating, I will do 4 and exit. So this is how the program to implement a circular queue of characters can be implemented and executed. Thank you.